Welcome to Mathematics Lecture Series, Higher Derivative Lecture number 24 in Applied Calculus Series. I request you kindly subscribe the channel as you find more videos on mathematics topics. If R is any position vector, so first derivative dr by dt with respect to time of the position vector is r dot. This is denoted velocity or speed. Second derivative r double dot is denote acceleration. Third derivative, this is denote jerk. Fourth derivative is snap or bounce. Fifth derivative is denote crackle. Sixth derivative denotes pop. So in this lecture we discuss higher derivatives. Let y is equal to f of x is any differentiable function. Its derivative is exists in the interval ab, open interval ab. If we apply the definition or derive this differentiable function f prime of x or f dash x, if the resulting limit, if it exists, will be the second derivative of y is equal to f of x and is denoted of y double prime or y double dash f double dash of x. Y double prime f double prime of x is equal to limit h tends to 0 of the derivative function f dash x plus h minus f dash x over h. If this limit exists, we can say we will have second derivative y double prime. Here are some notations. Y dash f dash of x first derivative notation d of x, we can say this, we can also denote by d of x or y is equal to d of x y is equal to dy by dx. Similarly, y double dash f double d square x y d square y dx square. Similarly, d3y over dx cube d3xy f triple prime x y triple 3 y triple prime triple dash. This is a notation of third derivative, fourth derivative, n minus one's derivative y, n minus 1 f of n minus 1 of x or d of n minus xy d of n minus y or d of x, and similarly nth derivative notations. Here is example on second derivative. If y is equal to tan inverse x, show that 1 plus x square y double prime plus 2xy prime is equal to 0. So y is equal to tan inverse x. Differentiate twice. So y dash, what is the derivative of tan inverse x? We know that 1 over 1 plus x square. Both sides multiply with 1 plus x square. So 1 plus x square y prime and 1 plus x square must be, when 1 plus x square we will have just 1. Again differentiate. So here we use u into v formula. Means 1 plus square x square is same. Taking the derivative of y prime, so it becomes y double prime. Y prime is same. Taking the derivative of 1 plus x square, 1 derivative is 0, x square 2x is equal to 0. So 1 plus x square y double prime, here 2x y prime is equal to 0, and we have to prove this quantity. Another example, if y is equal to log ln x plus under radical 1 plus x square, and prove 1 plus x square y double prime x y prime is equal to 0. Differentiate both sides with respect to x. So here y prime derivative of ln 1 over x. So here x must be x plus radical 1 plus x square. So derivative of ln x radical 1 plus x square is 1 over x plus radical 1 plus x square, and derivative of this denominator x plus radical 1 plus x square. So here derivative of 1 is 1. This is square root derivative 1 by 2 1 plus x square minus 1 by 2, and derivative of this 1, derivative 1 is 0. What is derivative of x square? 2x. So 2 must be vanished with this 2, and we will have after LCM square root 1 plus x square plus x. In this quantity we will have in denominator, so must be vanished, and we have the rest 1 over 1 plus 1 over under radical 1 plus x square. So both sides multiply square root 1 plus x square. So we will have square root 1 plus x square y prime is equal to 0. Again differentiate. So 1 plus under radical 1 plus x square, what is derivative of y prime? It is denoted y double prime. Now taking the derivative of under root 1 plus x square, so 1 by 2 1 plus x square minus 1 by 2, and derivative of base 2x. So y prime is same here. Here you can see, we can write it in denominator, it becomes under root 1 plus x square. 2 cancel with 2, so x y prime over under root 1 plus x square. So just taking the LCM, and we will have 1 plus x square y double prime plus x y prime is equal to 0, and we have to prove this quantity. If y is equal to sin it, we have to prove y double prime tangent x y prime plus y cos square x is equal to 0. So given that y is equal to sin x, differentiate twice with respect to x. So we denote derivative of y dash, derivative of sin x, so cos sin x, and derivative of angle cos x. Taking another derivative, so y prime, y double prime, we use the u into v formula here. Cos sin x, derivative of cos minus sin x plus cos x is same, derivative of cos sin x minus sin x, and derivative of sin x cos x. So minus sin x cos sin x, here plus minus minus cos x multiply with this cos square x sin x. Here we just multiply and divide with cos x, so minus the sin x here, cos sin x, and we multiply and divide with cos x minus cos square x sin is the and this follow this step. So here cos x cos sin x, you know that this is y prime, cos sin x cos x, this cos sin x is equal to y prime, and you know that sin x or cos x tangent x minus cos square x sin x is equal to y as it is given. So we replace sin x with y, so we will have y double prime, take on that side, minus becomes plus tangent x y prime, take to that side, plus y cos square x is equal to 0, and this is required proof. Thank you. I request you kindly subscribe the channel.